My name is Nandini. Here, welcome to video series of operating system. Here we are discussing about introduction to part process states, and here definition of process state. A process is not just a collection of guidelines. Among other things, it holds data from the process stack, the program counter, and the content of the process register. A process alters the system state as it executes. The condition of a process as a whole is determined by its current activity. Next thing, here we are discussing about some of the significance of a process state, effective time management in order to maximize CPU utilization and guarantee that high priority activities are completely promptly. The operating system uses process states to manage the priority which process should be executed. Management of resources. The OS can more efficiently allocate resources while it is different states. For example, the OS can efficiently allocate CPU time to process by knowing which one are in the ready condition. Continuity. The OS can enable several processes to execute currently, increasing the system throughput and performance by managing processes in different states. Separation and defense. States make sure that process don't conflict with the one another. For instance, an operating system process cannot be interrupted by halted process that is awaiting IO system. And next thing, separation and defense states make sure that process don't conflict with one another. For instance, an ongoing process cannot be interrupted by a halted process that is awaiting IO. Preventing and identifying deadlocks. By monitoring process states, the operating system can prevent and handle deadlock situations in which two or more processes are waiting endless for resources that they jointly own and stability of the system. Process state management done right aids in identifying and resolving problems like resource and congestions and unresponsive process, which in turn promotes overall system stability. And next thing, experience of the user. The OS can give user more responsive and seamless experience by effectively managing process and their state, allowing apps to be launched, interrupted, and resumed with easy. Monitor and debugging. Administrators on developers can find bottlenecks and improve applications performed by tracking the status of process, which aid in debugging and performance monitoring of the system. Windows process states in Windows. Here we are following few more steps in Windows process state. First one is new. Throughout it has not begun. The process is currently begun develop. Ready. This process is awaiting CPU time and is prepared to begin. Running. The process is running at the moment. Block. The process is awaiting a resources event like completion of the IO. Suspended. Although dormant, the process remains in memory either of the ready suspended or blocked suspend. In ready suspended, all sets suspended, not in memory at the moment, but awaiting for CPU time. Block suspend, not a memory at the moment, waiting for a resource. Terminated, a process being deleted from the system after it has finishing the running. And next one is Linux process states. Running and sleeping, stopped, and zombies and idle. Running. The procedure either running or prepared to run. And sleeping, the procedure is awaiting a resources or event. It might be interruptible sleep or uninterruptible sleep. In interruptible sleep, subject to signal arousal and uninterruptible sleep, as usually occurs while awaiting hardware and cannot be interrupted and stopped. The process has terminated typically as a result of a debugger or a single zombie. Even after the process has concluded, is still included in the process table until the parent process reads the exit status. This state is permanent present. Ideal mainly for ideal kernel threads. And the next one is task dead, task walking on task walking. The process is currently being halted just before it turns into zombies and talking walking, like uninterruptible sleep, but with the ability to woken up by signals and task walking. The process is awakening with a slumber. Here you can see the diagram. In this process, next one is process states in Windows. In process states, it can be occur in few. And in first one is new process state or creation. This procedure has been established, but it has not been set for run yet. And in this new process, transaction is after a process has been initiated and it is prepared for operation, it going from the new state to the ready state. And next, ready state, after being loaded into memory, the process is awaiting CPU time to begin. And next, transition of ready processes to running and to waiting. Into running, when the scheduler decides to let the process use the CPU, it enters the running state. And next one is to waiting. A process may enter the waiting state if it is needed, a resource, or waiting an event. Next thing is running. The CPU is presently running the process, and in transaction to ready, the processor enters the ready state if he scheduled permits. To waiting, the process enters the waiting state when it must be wait for IO operation, input or output operation or other event. To terminated, the process enter the terminated state when it execution finished. It ends because of an error and waiting. The procedure is waiting occurrence of an occasion or the availability of a resource. Until the event happen or resources become availability, it can move to forward. Transition of the transition of waiting process to ready and to terminated. To in ready, the process returns to the ready state when the resources or event it is awaiting because of available become available. To terminated, the process may occasionally go straight to the terminate state if it is terminated or if it runs into an unrecoverable problems. And terminated and last state in this indicates the process has either come to an end or has been put to rest. It is now the point where the operating system can clean it up. Transition. The last stage of process. In this process, the state does not undergo any additional transactions. And next, transaction between the states and conditions trigger the transaction. Transitions first one is new to ready after the in this state this transaction after the completion of a process setup. Next is one is ready to running when the process is given CPU time by the scheduler. And the next one running to ready. When the scheduler interrupts the process. Next thing is running to waiting. When a procedure needs wait for things like events or resources. Waiting to ready. As soon as the resources or events is made available, running to terminated. When the procedure ends or finished, waiting to terminate. If the procedure is stopped before the occurrence takes place. And next in conditions that trigger the transaction. In transactions, you already know that in new to ready transaction, the process is now completely and operational. In ready to running transaction, the scheduler allowed CPU time to process. In running to ready transaction, because of the higher priority process requires CPU or because it is time to slice has expired, the process is halted. Running to waited. Something has to be wait on the process, such as input or output activity or a resource. Waiting to ready. The process receives the time it was waiting on and running to terminated. Either the process completes or fatal error occurs. Waiting to terminated while the process awaits it is ended. You can see the diagram here new to ready and you can see the transactions here. First one is new to ready is admit and ready to running is dispatch. And you can see the next is transaction running to ready is timeout and running to exit release and running to block event wait and block to ready event occurs. Thank you.